Okay, so today's video is going to be looking at Chapter 8A, which is talking about reducing balance loans. Reducing balance loans are loans in which we are paying back, where we are also charged interest, and that interest is charged as a compound. So therefore, whatever is owing on the loan, we are charged interest for that. If you wanted to have a look at a visual way of seeing a reducing balance loan, it's a loan that's going down, but for each repayment we make, we are charged a small amount of interest. So not enough interest that it's overthrowing what our repayment is, but just enough that we're taking 2 steps forward, 1 step back. So when I go to make another repayment, I'm making that loan go down again, but I am also charged a little bit of interest. So I'm taking that 1 step back. Again, my next repayment, paying a part off, so 2 steps forward, but then I also am getting charged interest for that, so I'm taking that 1 step back. Now the amount of interest that you're charged is dependent on the interest rate itself and how often it's compounded. Now we know from the last chapter that when I'm investing money, I want lots of compounds. When I'm borrowing money, I want a smaller amount of compounds, purely so I can save money. We're going to be looking at example 1 and 2, which is talking about how we can work out how much more we owe on the loan after a certain amount of time periods, as well as how we can also work out how much interest we actually pay. So it's always good to know that yes, I'm paying off the loan, but how much extra am I being charged in order to pay it off? Okay, so with both of these, they can be based off recurrence relationships. Now I've written the relationship already up there. If you're a little bit unsure as to how I got to that, have a look back in the Chapter 7 videos. If not, if you go to page 324 of your textbook, that'll give you a brief outline as to what each of these mean. So starting with this, we've got a few unknown values that have occurred previously to us. R is still our rate, N is still our number of compounds, A to the subscript N is still our payment or how much is owing, whereas capital R, this is something new to us, that is the regular repayment. The regular repayment will always be given to you in a question. Keep in mind, we will always tell you that as well. Because we've never used this one before, I'm just going to put regular repayment. Pardon me. So looking at example 1, Alyssa will borrow $4,800 and will be charged compound interest at a rate of 15% per annum, compounding monthly. She will make monthly repayments of $300 to repay this loan. Firstly, construct a recurrence relationship. This is what we have here. Secondly, apply this relationship to determine how much Alyssa will still owe on the loan after 2 repayments. So we're going to be looking at this 2 times. Let's write down the information we know. For example, I know my rate is 0.15. Now when we're looking at this recurrence relationship though, it's compounding monthly. So we're going to put divide by 12. The initial value, well for our first calculation, our initial value is going to be 4,800 because that's how much the loan's for. This will change for our second calculation. Our end value is the amount of compounds that occur for that year. That's 12. Now one thing we need to keep in mind with this R value is that when we go to implement it into the formula, R is actually 1 plus R, or 1 plus I, what our rate is. So I might put 1 plus I. Now we've seen this before when we use our compound interest formula. What this 1 actually does is accounts for the whole value plus the additional interest. So for my first calculation, I'm going to rewrite that formula. And I'm going to substitute those values in. So my R value my initial balance, my regular repayment, which I didn't write on there, is $300. So I'm going to go enter this into my calculator, making sure that I put brackets where necessary. Now, you can see what I've done here. I've put 0.15 divided by 12. What I might do in my working is include the 1 plus 1, just so we don't get confused. So that's what I've mentioned up here, and that our R value also includes 1 plus. So I pop that in brackets so I can do that all together. So my first value is 4,560. So this is how much she owes after one period. Okay? So we're going to do this one more time because the question is asking us for 2 periods. So I'm going to keep this formula here, but I'm also going to account for the things that change. So previously, for this calculation, our initial amount was 4,800. For this next calculation, our AN value is going to be what we actually got for that answer there. So 4,560. So I'm going to put 4,560. Our repayment will remain the same, our rate will remain the same, and our compound periods will remain the same. So following that same process again, 1 plus 0.15 divided by 12. Again, you might just have the answer straight away there. That's okay, you can write that in. Multiplied by our previous amount minus the repayment, which remains the same. So when I put that into my calculator, I get 4,317. So what we've just calculated there is that after 2 periods, she will have $4,317 remaining off her loan. How much did she pay back? Well, we could calculate that by taking this value away from what she started with. The question's not asking that for that though, but that's something that we can keep in mind if we're asked for in future. Okay, so looking at example 2, we're focusing on how we can calculate how much interest we've actually paid throughout the loan. The reason why we might do this is if we're trying to reevaluate our loan conditions, such that we might want to look for something that has a better rate or something that might compound differently. We have a different type of relation for this. Now this is in your textbook, but we can also break it down by basing it on concepts that we've learnt in chapter 7. So what we have straight away is the interest we've repaid equals n, so the number of compounds, times our rate, minus the amount we started with, take away the previous balance. So essentially we're doing the total repayments we've made minus what we've reducted in the principal itself. Now with this question, it does involve concepts that we've done in example 1. So that's why I've left it up on the board. So the question says, Henry will borrow $25,000 and will be charged compound interest at a rate of 8.4% per annum, compounding quarterly. He will make quarterly repayments of $1,500 to repay this loan. So in order for us to work this out, we can't jump straight into the formula. Yes, we do know the number of compounds, it's 4. Yes, we do know his repayment, it's $1,500 I think. Yes, we do know the starting amount, which is $20,000, but what we don't know is what the previous balance is. So we need to calculate that. In order for us to do that, we have to do what we did in example 1. So what I'd like you to do now is to take a moment and use the concept we've done in example 1 to work out how much he owes at the end of that year. So that means you'll be doing this 3 times. You'll be doing it for the first compound, the second compound, the third compound, you'll be doing it 4 times, and the 4th compound. So pause the video. I'd love you to have an attempt at solving that. Okay, so now that you've applied those compounds, you would hopefully have an a to the n value of 15,542. Now there was quite a significant decimal. I'm rounding that to 2 decimal places. So if I was to do that, I would have $15,543. So now I've got this missing piece of information that I can use to apply the formula. So I'm going to have capital I equals N times R minus AO minus AN. N is 4. Our repayment is 1,500 minus 20,000 minus 15,543. So if I go to substitute that into my calculator, remembering our order of operations is quite important here. So after this loan, or from 1 year, he has paid $1,543 in interest.